Good afternoon, everybody. I'm sorry I'm going to interrupt your super nice scientific discussions, but I hope that you also enjoy talking a little bit more on innovation and what do we need to bring all this super nice research to or closer to the market. So that's the idea behind the European Innovation Council. So this is the outline of my presentation. So I'll briefly introduce the EIC for those of you that do not know the EIC. Hopefully most of you, at least the European ones, you know it. And then I'll go through my portfolio, especially on the advanced computing very quickly, and then a little bit of future outlook and what we need from this community so that the things, let's say, really happen now. So the European Innovation Council was created 5 years ago to bridge some gaps, especially in Europe where we have very good research, but we are not being so keen on bringing them to the market. Probably here, this is not the best context because we already have like 4 or 5 startups in the field. So this is very nice. And those are very nice experiences that we can showcase today. So it's a 10 billion euro budget under Horizon Europe. And it's specifically to identify, develop, and scale up breakthrough technologies. So it's really about deep tech, disruptive innovation. So bringing all this research to the market. For that, we have put under like a one-stop shop all technology readiness levels. So from very early stage research ideas all the way to commercialization. I will show you the programs very fast, very quickly in my next slide. But we also have what we call funding, different funding approaches, but one can be from the bottom up. So most of your projects are coming from bottom up. So you just present your idea, and whatever is in there, it will be evaluated. But we also have what we call challenges. Myself, as program manager, I am running 3 specific challenges dedicated to putting a little bit of sustainability in terms of in the electronics. Another special feature of the EIC is that we are steered by a board. For those of you that know the European Commission, we don't always have external boards to steer the strategy. So this board is involving entrepreneurs, investors, which is a little bit different. My role also as program manager is very specific of the EIC. There are no program managers on the other programs. So usually it's project officers, but they don't proactively manage portfolios of projects. And then we give a lot of importance to partnerships. So we really are building everything that is needed to create the ecosystem for the innovation. So it's not only about funding, it's also about helping in creating the ecosystem. And finally, super specific is that we have this EIC fund managed by the European Investment Bank. So we invest in selected companies from the EIC. This is the roadmap that has been created to bring all this very good innovation coming from the Pathfinder all the way to become a startup. So the features are, I already talked about the program managers. So the first, most of you know it, funding mechanism is Pathfinder. So it's we give grants up to 4 million euros, and it's really for to bring ideas closer to TRL4. So this is the first step that you would do as a researcher. The next one is transition. So for example, spin ion has a transition. So transition is for, it can be consortia, but it can be single companies, and it's really to develop the business case. We give grants up to 2.5 million euros. And then, well, this is very new, the pre-accelerator, which is to prepare the accelerator, which is our STAR program, which is for startups. We give grants up to 2.5 million and also equity up to 10 million. And this is really to enter the market, to scale up your company. The pre-accelerator was created only for what we call the widening countries, so countries that have difficulties in being successful here. It's just grants in preparation of the accelerator. And then this is also very new, this is STEP program, which is for the scaling up of the companies. So we just co-invest up to 30 million euros. And as I said, very important for us are the creation of smart money. So we don't give money here, but we help with mentors, with coaches, innovation, creating innovation ecosystems, corporate days. So there are many activities around what we call business acceleration services, and then well, a couple of prizes. And so it's not that you need to do this whole path, let's say. You can jump anyway in any of the programs, but the idea is that how can we do so that researchers like most of you are happy to and can have how can we facilitate your road to become an entrepreneur, to start with a startup. So that's the idea. This is the budget for 2025, so it's nearly finished now, but so just to give you some numbers. So for Pathfinder this year, there were 260 million euros, in the open 140, in the challenge is 120. This is really very low numbers for the amount of proposals that we have received. And this is the case for all our programs. So our programs are really competitive, and it's very difficult to be successful. Transition, a little bit less than 100 million, million euros. Accelerator, 250 for the challenges, 384. So this is the star of our program, really the one dedicated to the startups. But everything is preparing the road to become to commercialize the research. And then, as I said, this is very new step for scaling up startups. Just one slide on the impacts. So we have completed a good number of investment rounds, which probably is not so important here. Created more or supported more than 700 startups. That doesn't mean that we support them with money, because as I said, it's very competitive and we're not getting there. But I wanted to mention that in this case, if we talk about the strategic technologies, quantum and semiconductors are the largest, let's say, thematic or strategic technology receiving money from our 3 programs. So this was not the case some years ago, a couple of years ago. It was mostly medical devices, but now quantum and semiconductors, and AI is the second one. So this is really very important at this point. This is a little bit how the project portfolio looks like. So you can see that there are a lot of medical technologies in number of projects, but you can see that the second one is already quantum and advanced computing. I'm not going to stop on this one, but this is to show you that we cover a large amount of the different sectors and countries. So now I'll come to my portfolio. So my portfolio is about sustainable electronics. So looking at the entire life cycle of the electronic devices, not only design, but also manufacturing, and especially the device use. So energy efficiency is part of my portfolio of projects, looking into the energy efficiency. And you will see that I even have a challenge on that. This is the portfolio that I'm managing, so it's huge. You can imagine that I cannot follow the projects, all those projects, because it's more than 125, and this is 657. I just wanted to highlight that this is a taxonomy that probably nobody likes, but this is the taxonomy being used by the European Investment Bank, and we need to follow it. So you can see that already in advanced computing and logic systems, there are many projects already in Accelerator and also in Pathfinder, not so many in transition. And then there's another taxonomy called spintronics and magnetronics. You can see that we only have projects in Pathfinder. That doesn't mean that we have projects in transition that are working with spintronics, but this is the terminology that is being used internally. With this is my first, I'm not going to say message, but we see, and we will see today, we have many projects in architectures based on spintronics and on others, and we are not so successful in bringing them to the market. So we need to do something and to understand why this is happening, even if we have very nice success stories. I took this slide from CV Insights, so just to mention a little bit and to try to classify the projects that I'm following. So if we call novel computing approaches, we have photonic computing, neuromorphic computing, quantum computing, and biological computing. And we have projects running on all of them. Some of them are mentioned here, some of our startups. I'm not going to stop here. It was just for the classification. So first I'll come into the quantum computing. So EIC is the largest public investor in quantum technologies in Europe. So in this case, there are many startups around quantum computing. I just mentioned 2 of them, Quobly and Luxuanta, but there's another program manager managing this. For each portfolio, in the case of Pathfinder, we elaborate this kind of strategic plan. So there's a strategic plan, which is a public document, in case you're interested in understanding what I think it's 8 projects dealing with quantum computing at Pathfinder level, what they are doing. So this is a public document, just in case you're interested. I go to the DNA computing. So I'm managing a challenge which is called the DNA-based digital data storage. So it's mostly about the storage, but they are also, a couple of projects are doing a little bit on computing also. This is super long-term. There's not much mention in this strategic plan that we are elaborating. It's mostly about the storage part. But for example, this project coordinated by Maynooth in Ireland, they also are trying to do some DNA computing. A couple of other projects, DNA fairy lights, 3D bricks, all those are Pathfinder projects dealing somehow with DNA computing. On photonics, I could spend a lot of time talking about photonic computing because we have many projects around photonic computing, not only the part of the computing, but also enabling technologies for computing. I'm just mentioning some on software, some others more on the computing per se, but photonics is one of the largest portfolios that we can have because Europe is very strong and we are pushing for that also. So this is really large. This is just, those are examples. So we have many more than those. And those are startups. Most of them, I would say all of them now are in accelerators. Ipronics was in transition, and this year they got the accelerator. And then coming closer to this community, so to the neuromorphic, we also have some startups. I think here today there are some. If I recall correctly, I think Inaterra was coming, and also Nello, I think it was here. So what we have some startups in the neuromorphic chips. Some of them are in the accelerator. Some others are more on the transition side. But still, we feel that for the amount of money and the amount of research in Europe, we should be pushing for more. And this is something that maybe we can explore later in the discussion. Some examples of very fundamental research that we're doing in neuromorphics, not only on spintronics, but on other things. So those are mostly flexible electronics or printed electronics, both of you, those. But there are many other projects. I think today Highbrain will also be showcasing. I'm not, Insect Neuro Nano, I think tomorrow, right? Maybe some others. So some of them will be, you will hear about what they are doing. So I don't want to stop on that one. And also more on the spintronic side, we have many projects also dedicated to this. Some of them, or most of them, are also going to be presented today or tomorrow. And with that, I would like to finish a little bit more on understanding what this means in the strategy of Europe. So all this program is very well embedded in the EU strategy. So it's not very clear in the CHIPS Act, first one. Sustainability is not very clear now. In the second CHIPS Act 2.0, it's going to be a little bit more clearer. We also, because I work a lot on materials, so we are part of the European Critical Raw Materials Act. We are very well embedded in the Advanced Materials Initiative. And of course, these strategic technologies for Europe platform, of course, semiconductors are everywhere, advanced computing. So we are in the middle, in the heart of this step. So this topic is absolutely one of the strategic technologies. Strategic technologies is part of the sovereignty approaches. So we are very well here embedded. This is a PDF, so you cannot see my what's beneath that one. Okay. Anyway, with that, I wanted to show that yes, the overall growth in the global semiconductor market is well, it's very important. It's driven by computing and data storage mainly, but also wireless communication and automotive and industrials. This is especially in Europe important. I had here there was another graph where you could see that neuromorphic computing was growing at exponentially. So that's what I wanted to show. That neuromorphic computing is a graph from Joule. I don't think it says there because it's hidden, but a graph from Joule showing that there's an exponential growth expected for neuromorphic computing. So you're in a nice field to really make it grow and make it happen. And with this is my pre-final slide. So this is about Europe. So where are we in Europe? So Europe is this, let's say this blue, the light blue here. So, okay, we are not so bad in equipment. You know, everybody knows about ASML. We are not so bad in design and in the software. This is on the software side. This is mostly, well, we know that what we have bought. So this is material, we are okay. But if we go for the manufacturing part, integrated circuits, foundries, we just disappear. And then I took this graph on where can startups, because we are pushing for exploitation mostly through startups, not only. So we can see that in this case, EU is the same little color here. So you can see already that in design, the number of startups in Europe, let's say it's 63, of course, is much lower than in China, but it's the highest amount. So we go from something which we are not so relevant to start being a little bit more relevant. So we think that we are pushing for many startups in design, in IP also, and this is somehow showing a little bit of success in that case. And so there's a lot of, we had 2 challenges on chip design, especially to push for this. And I think this is rewarding now the efforts that we had. And yeah, with that, I was just going to conclude that we have a huge pipeline of innovations in semiconductors in Europe. We are contributing to very relevant policies. Also, the Green Deal I didn't mention. We didn't talk about the long development timelines and huge investment needed for semiconductors, but all of you know it. Then it's also very important to mention that it's very difficult for many of startups to grow in Europe because they cannot find relevant active end users, system integrators. But I wanted to say that maybe neuromorphic computing can be different. And this is an open question on how can we facilitate this path to commercialization of all this basic research that we are doing. This is an open question for you. So I wonder what's missing so that all this that you are developing, how can we help you in bringing it closer to the market? How can we promote it? I know money would be the first answer from your side, but I guess there are other topics that maybe we need to build, and this is one idea behind this workshop. How can we build ecosystems? How can you collaborate among you so that this is a field that can grow? Because we see that in Europe, we are pretty strong in that. So hopefully we can leverage on this research. Thank you very much. With that, I'm done, and I would like to introduce the rest of the projects in the portfolio, in the EIC portfolio.
Hello, thank you for the presentation. I have a question on one of your slides that showed the geographic distribution of the funds that you're managing, and I'm Romanian, and maybe I'm a bit biased. So I have it looks to me, if I do a quick regression, that maybe West is favored a bit over all of the potential brains that exist in Eastern Europe. Is there something to do to invigorate the startup, the entrepreneurial mentality in those countries?
Yeah, there are specific programs for that. I think I mentioned that in this case, this year, this pre-accelerator is especially for that kind of countries because we see that it's very difficult to compete also in our program. So if we don't push a little bit and help those countries that are not so, let's say, successful, they don't have the ecosystems, it's very difficult for them. So there are several activities. I'm just mentioning this one because this is very new. This is from this year. So we give grants to help startups to present their proposals to accelerator in a, let's say, in a more successful, or hopefully more successful. But there are many activities. We have many info days. For example, I was in Poland at the end of August. So we try to go to those places where it's more difficult, try to bring a little bit the message of what we want to build. But we see those differences, and we understand that it's very difficult to bring this research to the market. That doesn't mean that there's no good research, but the ecosystem is not created for the startup evolution, and we see that there are several programs for that. But indeed, that's going to take, I think, a little bit longer. But some activities are being done around that.
Thank you for the nice overview. I have two specific questions, even if they are related. The first one is you asked what is the missing link in order to bring in these more technological developments. I think really what is needed for the more hardware part is link with the CHIP Act and access to pilot lines to these startups, because there are some large investments. So I think having a more aligned strategy of the CHIP Act with what the startups are covering as topics is important.
I can even answer, because this morning while I was coming on the train, I had a 1.5 hour meeting with DigiConnect exactly on that. So it was exactly on public procurement. How can they build the public procurement of the pilot lines in such a way that also the startups can have like an easier way? And also this is going to, or we are trying that this happens for the AI factories. In the AI factories, they will need to buy some chips, and I think something will be there. Yeah. So we're working on that. So that's one of the activities that we were discussing. And also, why don't the pilot lines leave some space in their...
Exactly. There is, for example, the Prevail project, which is AI related. So there were some large investments around the RTOs. So I think this should be even more connected.
I fully agree. And we are fighting for that. This is DigiConnect. I don't do the policy. I can only suggest from what I see, because I also listen to the startups, and I see that there's a need also in locating some equipment, for example, in a pilot line. So people developing, I don't know, I have a company developing very advanced lithography. They claim that maybe they can compete with ASML. Why don't we put it in the IMEC pilot line and try to help them in testing that kind of thing? So hopefully in the CHIPS Act 2.0, I'm not sure what will be super well described, but something more in relation to procurement with the startups and all that. Hopefully it will be...
So around spintronics, there is this spin chip project, which is in the CHIPS GU, which was submitted in the second stage. So this should contribute actually to make the link. There are some startups involved.
But it's very difficult for the startups to be in the CHIPS GU. All this program with 3 different legs, and they have to ask money. So we are also working with the CHIPS GU to find a different way for the startups also being funded 100% by maybe their regional or their national. So yes, we're working on that, and we see, because I try to listen to the startups, and we are doing things. But yeah, this is a final decision. It's coming from DigiConnect. Yeah. Thanks for the ideas anyway.
Yeah, thank you, Isabel, for this overview. Yeah, I would like to add on to that. I think for research and maybe startups to be, it's very essential that if they come with new exotic, let's say, technologies, that they have a place, people to spar with. How can we bridge finally to mainstream technology? Because even if you can go on a pilot line, let's say at IMEC, it's very costly if you have to go for mask, and it's just infeasibly expensive, which is understandable but unaffordable. So I think there's really a missing link. Maybe it's just hard to find, or maybe it's not existing, but at least we see this now to bridge into transition, that this is really a challenge, finding the right people, finding the right expertise to come with your kind of new technology and bring it closer to mainstream.
Yeah, indeed, those are the kind of things that we are working on. I meant more in the specific case of neuromorphic computing, that Europe is so strong. What can we do specifically? What do you need exactly in terms of scalable deposition methods? So what do you exactly need to make this happen? But in general, I fully agree with you. The embedding of the startups in the whole CHIPS Act ecosystem and all that, it's super important, and we are working on that. And it was not well embedded in the first CHIPS Act. So hopefully in this second one, it will be a little bit better. We are also working with all the RTOs, with the pilot lines, to see how we can also bring these technologies closer to what they are doing, and to... So one of the demands, because I've been talking to 4 of the 5 pilot lines that have been selected, that have started, 4 of them, they really want to work with the startups, and they were saying, okay, procurement is very nice, Isabel, but I also want the startups that become my clients. So, and I could give them like special prices, because I would love to have all these novel technologies also in my pilot line. So everybody wants to do it. Let's see how we how we can make it happen. But yes, I fully agree. My question was more on the specificities of neuromorphic computing,
Yeah,
maybe.
in my case, it's also neuromorphic, as you know, but yeah, in general, it's true.
Yeah.
Thank you.